Certainly not least, I'd like to introduce Ben Gelman, who will be speaking about online urbanism, interest-based subcultures as drivers of informal learning in an online community.
Hello everyone, my name is Ben Gelman, as she said, and I will be presenting our paper, Online Urbanism, Interest-Based Subcultures as Drivers of Informal Learning in an Online Community. Okay, I know that's a lot to take in, but let's start one step at a time. So the purpose of our work is to fill a gap in the understanding of the growth of online communities, specifically informal learning settings such as online communities of creators. We'll review those terms in detail shortly, but basically there's a lot of communities online nowadays where that the youth are participating in, and they're learning a lot from the internet. And that's not measured by MOOCs or examinations or anything like that. And additionally, we analyze the temporal effects of population growth on user interests and social network structure in these communities. Our findings draw parallels with real-life urbanism, and they provide guidance in online community design for evolving interest-based communities. So in this presentation, I'll first introduce relevant terms, followed by what you need to know about our data and its structure. And then I'll discuss our methodology, our clustering method, how we validated our results, and additional information we gathered about clustering using temporal analysis. So first, informal learning is different than what you'd expect in a classroom setting. As Victoria Marsick put it, informal learning is predominantly unstructured, experiential, and non-institutional. Your development in an informal learning setting is a consequence of your actions and experiences, rather than being an explicit purpose. Also, informal learning may need to be measured through the context of your domain, rather than examinations of a classroom setting. For example, RuneScape. This is an online game I used to play around 12 years ago. And the picture shows a place where hundreds of players would stand around typing what they wanted to trade with other users. But if you type too slow, your chat would actually be overwritten by the other players. So the most successful merchants would rapidly type the same messages hundreds and even thousands of times. And so even though the game didn't track typing speed at all, that was not an explicit purpose of the game, you could actually probably measure that ability using a player's wealth. This is how I learned to type, and when I was younger, it actually bolstered my interest in computers and eventually propelled me to start computer science. So these little informal communities can have a big effect on how people grow up and develop and what they learn. So in any case, to hone in on informal learning communities, we look at online communities of creators specifically. These are essentially social network sites where the core activity of members is sharing their own creations. And informal learning is often heavily infused in the making of those creations. So Scratch is an online community of creators and the focus of our study. Scratch provides users a visual programming interface where computer science concepts are represented as jigsaw-like pieces. Users can put together those puzzle pieces to create working programs and games and stuff like that. And additionally, users are able to post their projects, edit source code of other users' projects, follow other users in a social network sense, and chat via various mediums. All of this information constitutes our data set. And here's a picture of what the Scratch interface looks like. So in part A, you can actually see the program occurring at various parts of your script. So as you program it up, you can see what your project will look like. In part B, you have block selection, which allows you to choose from all the programming puzzle pieces that Scratch provides. And part C shows the current script, and there's like puzzle pieces already attached, and that's how you do control flow and things like that. So in addition to the project code, the follower connections and communications, this is some other basic information about our data. Between March 2007 and April 2012, there were 1 million registered users and 2 million projects. And the site featured 170 of those puzzle piece programming constructs that users could place in their project. And of course, each construct represents something different, like an if statement or a while loop or Boolean logic, things like that. So last note on the data here, the activity of users exhibits a long tail phenomenon. So this means that for any measure of activity, as the measure increases, the frequency of users with that level of activity decreases. So in Scratch, we can see that as the number of followers increases or the number of projects you post increase, the amount of users that are actually able to achieve that much inside the data decreases very sharply. Okay, so moving on, I'll introduce our clustering method. So first we limited our space to users with 25 followers. And we found that if we lowered the threshold too much, we got users that were not good representatives of the community because they either barely posted any project or they actually had friends in real life, which are not a very good representation of an online community. So we didn't want to include them. But if you increase the value too much, then you actually skew the data towards older users who've been on the site for many years and have had more time to build up followers. So we settled on 25, and we plotted our data in Gephi, which is just a graphing and visualization tool. One of the projects earlier actually used it. And we use the OpenORD layout to do the clustering, and OpenORD is a multi-level layout that uses average link clustering. So basically, multi-level means that you cluster your data, you replace it with smaller points, or you replace similar points with a single point, and cluster again. And you can repeat that for however many levels you want. And at the very end, it expands those supernodes and returns you to your original graph. And each level of clustering just uses your standard average link hierarchical clustering. So here's the clustering results, and after running OpenORD, we obtained 5 clusters. And in order to understand their meaning, we gathered the project titles, descriptions, tags, and comments for each project in each cluster. And we then assigned themes based on word frequencies. So we did a bit of text mining on each cluster. So this updated figure shows the themes that we found in each cluster. We weighted the terms using TFIDF, which is the term frequency times inverse document frequency. And this essentially decreases the weight of terms that occur in many clusters and increases the weights for terms that occur in few clusters. This is a great method to use if you want to find unique terms and give them more weight. So the top words table shows the TF-IDF weighted occurrence of terms for each cluster. And in addition to just the text mining, we also took a random sample of projects from each cluster, which was very fun to go through. And given the samples and top terms, such as like compute, waffle, and funny, we were actually unable to determine a clear theme for the first 3 clusters, A, B, and C. But cluster D featured a heavy emphasis on playable games involving key presses and characters like Super Mario or Sonic the Hedgehog, which are terms that both appeared very frequently. And at first, the terms in cluster E seemed very peculiar. You have top terms like warrior, wolf, cat, art contest, and things like that. But the random samples actually really helped with that, and it turns out that the projects were actually user-drawn art involving canines, felines, depicted with weaponry and fighting each other and things like that. So after discovering these thematic clusters, we wanted to actually examine the temporal aspects of how this community came to be. So we used a sliding window approach, where each window contained users from the start of the data set up to a certain point in time. So you can see in the first window, that's all the users from 0 to 6 months. For the second one, it's 0 to 1 year. And sorry, I don't mean all users thresholded by 25 followers. So we clustered every single window individually using the OpenORD layout again. And in the first 3 years, we can see that clusters A and B become visually farther apart. This means that the relative connectivity between A and B is decreasing over time. So the users are actually following people within their cluster rather than across clusters. And right after 3 years, there's just a huge influx of users into the Scratch community. Tons of people start joining, and at first they form cluster C, but that quickly evolves into the next two clusters, D and E. And because the clusters emerged as the population grew, we actually needed a way to measure time and what was happening in between each section. So we coined a few terms called scratch age and scratch end. And they're pretty simple. Scratch age is just the age of a user's account from the start of the data set. But scratch end, on the other hand, measures the very last time that a user follows another user or posts a project. So this is like their end on Scratch. And a user is essentially considered inactive once they meet their scratch end. So here we have the same clustering layout, but with scratch edges and scratch end for each cluster. So you can see that the average scratch age, the SA average, is decreasing from cluster A through E. And that makes sense according to the sliding window approach we saw earlier, where the clusters formed from A through E. But more interestingly is the scratch end, which shows for that the thematically unclear clusters, you see that on average, users have not posted a project or followed another user in years. So clusters A, B, and C have 3.8, 2.4, and 1.1 years on average, where users have just not done anything. These results are interesting because time was not a factor in our clustering. We actually only clustered on follower connections. But because the open-ORD layout pushes away users based on follower connections, we see that the follower connections are inherently temporal. And this tells us that new users are not interested in following older, inactive users. And now to understand how the users were distributed at various time steps, we created this figure to display migration patterns. So if you look at the circles, the gray sections show the proportion of new users at that time step for each cluster. And you see that the arrows show the percentage of users in a current time step cluster that also were in the next time step cluster. So here's some observations. We can see that the gray sections that occur, they usually happen in the most recently emerged clusters. Also, we see very little inter-cluster movement, which means that if you look at an arrow at a cluster, it usually just points to the same cluster in the next time step. So what does this tell us? What does this tell us? It means that most users stay within the cluster they first identify with. And between years 4 and 5, most new users are joining the thematic clusters D and E. This means that after emerging, these interest-based communities are actually the most influential on new users in Scratch. So some limitations we had were the lack of demographics and our cumulative analysis. By cumulative analysis, I mean that our clustering included like older inactive users. And although this actually gave us insight into the network growth, it might have obscured detailed activities that happen in the young interest-based clusters. So in future work, we want to focus on both the most recent activity and individual user development rather than total network growth. This actually could allow us to create a recommender system based on a user's initial activities. Okay, so Fisher's subcultural theory of urbanism is the framework that we use for interpreting our results. The theory views subcultures as a set of interconnected social networks, which is most certainly a good representation of modern informal learning communities. And Fisher argues that population growth actually provides opportunities for similar people to group together, share traits, interests, and values in real life. But under this perspective, we can better understand our Scratch clusters by viewing them as subcultures, according to this theory. And to encourage informal learning in online communities, it's important to provide support to newcomers so they can actually express their interests and find a place within the community. This is especially important because we see that users tend to identify with whoever they meet first in the social network. So this is currently done by highlighting and curating certain interesting projects that target diverse users, but fully manual selection can be a convoluted process. And during this data set, there was 2 million projects in Scratch, And I think now it's something closer to 20 million. So it has grown even faster. But using our interest-based clusters for strategic curation, we can actually allow parts of the process to be automated, if not the whole thing, and make good recommendations for new users based on their interests. And yeah, that's all for our research on online urbanism, interest-based subcultures as drivers of informal learning in an online community. Hopefully all parts of the title are clear now, but I'm open for any questions.
So that was really fascinating, and we have plenty of time, so I want to take the opportunity to ask the first question. And that is, so we've been doing as kind of similar analysis in GitHub to see relations based on following. And one thing we've heard in interview studies is that people start following new projects or other users in spurts when they want to learn something new, which makes it very interesting from the standpoint of this conference. I wonder if you have any sense of what role following actually plays in the life of these Scratch users, and do you have any idea sort of where following occurs in their lifespan?
Okay, yes. It actually usually just happens mostly during times of activity. So when they first join, they tend to follow big users. So this might be an artifact of MIT's Scratch curation system. So at the time of this data set, they actually had MIT moderators browsing projects, going through the forums, seeing what people recommended, and putting these all over the front page. And we did some minor analysis that was not in this paper that showed that people actually tended to have to follow these featured projects that moderators curated. So indeed, the curation actually has a huge effect on where users first follow either projects or people that they're interested in.
So I have a question about the actual learning that's happening.
Sure.
Is there any analysis that you did on how the followers actually learn from the following process, or is there remixing going on, and how does that remixing speak to the actual learning? What are students' own projects looking like after a while? Not students, community members.
Yeah.
So yeah, if you have any analysis around that.
Sure, yeah. Interestingly enough, we actually had a paper at Learning at Scale last year that focused completely on project growth or vocabulary growth. So we analyzed how people used those 170 programming blocks and what they learned over time. And what we actually found was that there was 4 main groups. And these actually occurred regardless of interests. So even though there were interest-based clusters, people were learning programming vocabulary, like and constructs and how to program, regardless of their interests. And what we found was there were 4 main groups, and it was completely based on learning speed. So there were users that had very little prior knowledge. They joined Scratch. Regardless of the interest they followed, they were still able to learn, but they learned slowly. And on the other side of the spectrum, there were people that came in with high prior knowledge, learned a bunch of programming, they created their own projects, remixed, and learned a lot faster than people who came in with little prior knowledge. And we're actually currently working on a paper that will recommend project blocks, both based on interest and based on learning rate, so that users can learn these programming blocks faster than by going through and browsing the sites on their own. And yeah, I think, sorry, what was the last part of your question there? Right, let me see if I can go back to the slide here. Yeah, so these programming blocks, it's kind of hard to see, but there's 9 different categories, and they range from like control flow, logic, graphics, stuff like that. And you can see some of them, like the first one says when flag clicked. So it's just like, so it's basically just a conditional, right? That's what those project blocks are. And in our other paper, we analyze when when users first use these project blocks for the first time and the order in which they gain that knowledge. And yes, I remember you asking about the interest-based clusters. Oh, you asked about remixing, right? So yeah, we actually analyzed remix vocabulary in the other paper as well. And it turns out that very soon after remixing a project, users actually use the terms that they learned from the remix project in their own projects. Yeah.
Other questions?
So I wonder if you keep track of the interest of the clusters. For instance, if the users in the feline groups are keep programming the 5 years in the cats. So if the interest evolves over time, so I wonder how the migration of the users affect evolution of the interest, or if not, the interest stays in the 5 years. So my question is that if you were able to look at the change of the interest of the clusters.
Right. So let's look at this. Yeah. So I think, so we actually see that users tend to join the cluster, whatever cluster they first identify with, that's the one they stay in. As you can see, like cluster A has very high percentages between A each time. There's a few exceptions, but for the most part, it's pretty constant. And that might be an artifact of online communities in general, where people don't stay very long. So they come in, they work for a little bit, and then they're done, they're gone. So maybe when their interests evolve, they actually just evolve past the network itself. And if there were a way to measure inter-community, like different communities of creators, and see how people moved between them, I think that would be a cool study, but I don't know if there's any data available on something like that. But as we see in Scratch, people tend to stay in the interest that they first find. And I guess they leave after they're no longer interested, rather than changing interests.
As a follow-up question to that, and then I'll pass it on to our next questioner, I guess I wonder whether there's any evidence of whether it's positive or negative that people stay in the same cluster, and whether, for example, you might see a potential role for recommender systems to kind of suggest to people to look beyond the cluster that they're in.
Right. Yeah, so that could definitely be possible. I think that it would have to be something gradual. As we took the random samples, the users in, so we located where on the clusters they occurred, and the users in the center of the clusters most strongly identified with the themes of the cluster. So the ones in the center of the games cluster, for example, were completely playable games like Super Mario, Sonic, things like that. But as you moved away from the cluster, users showed a little bit of multi-interest, even though they focused mainly on the topic of the cluster. So if you went to like the edges of the game cluster, a random sample showed that one of their 25 projects might have been art, like they dabbled in it at some point, but they stopped showing interest in that topic. And I guess we would be able to recommend projects just on the edges of the other clusters as well, as a gradual moving into other themes. But I think part of the online urbanism theory is that people, as population grows, people find others who are just like them, and they want to be with those people, and sometimes they don't want to change the way they think.
Hi, Dan Russell from Google. Can you go back to the other diagram? Yeah, that one.
Yeah.
So each of these clusters represents a thematic topic, right?
Yeah.
And then in step 3, you have that A group fissioning into a minority 12% A and 78% into B.
Yeah.
Now, that's not the same B that we see in step 3, right? Or
Yeah.
is it?
No, it's not. So step 3, are you saying step 3 to 3.5?
Correct.
Yeah, so this was part of the clustering algorithm. It turns out that new users had joined at step 3. And between 3 and 3.5, there was just a huge influx of users. And this was probably the weirdest time in the Scratch timeline, where there were so many new users and they were browsing through all the previous content that was already there. The follower connections were just out of whack at that point. Even old inactive users and new users were being followed. And that might have just been like a new system that they had introduced at that point. I actually think that's when they changed their layouts completely. So Scratch had this point, approximately 3 to 3.5 years in, where they changed their interface, they changed the way they curated projects, and how they recommended projects on the front page.
So I'm curious because it looks like all the B people in step 3, 97% of them converted to C-ism.
Yeah, to C-ism, right.
Right.
Yeah.
And yet, so B remains, although none of the people are converted over from the previous B.
Right.
And that seems weird to me. Did those
Perhaps
B people at
we should have
3.5
relabeled, yeah.
independently discover the religion of B?
I see what you're saying, and I think the reason we left it like that is because the themes were pretty unclear in A and B, and quite a bit in C. Okay. So perhaps we should have relabeled that new B as some sort of new A subset.
That was my question. Go ahead. Keep answering it. Yeah.
Oh, well, sorry. What was?
So it's B prime, or is it really D, or I'm just trying to figure out relationship between B at step 3 and B at 3.5.
Right. I think it was something like only 3% of users had moved from the B in step 3 to 3.5. So perhaps that is poorly labeled on this diagram. That new B is more of a subset of A.
And they are literally new Bs.
They are new Bs, yeah. Yeah.
So I think that raises a really interesting question, though, for the analysis, because so at step 3 you said two things happened. There was a big reorganization, and there was also a huge influx of new users.
Right.
And that caused the clusters to reorganize themselves in some sense, right?
Yes.
What I didn't hear, maybe I just missed it, is that a lot of people left. It sounds like the people who were active weren't harmed by this huge reorganization. That suggests that we see people staying in their clusters, but it doesn't have to be that way, and that some kind of change in the structuring of the environment could lead people to be just as happy organized someplace else. So I think it kind of does raise some questions about well, what's the right thing to do then, and what's good for users? We have time for more questions, though. Other questions in the audience? Comments? Questions? Okay. Well, this has been a fascinating talk and a